Review for Part B test. Part B test is going to be Monday. Okay? Part B test is going to be this coming Monday. Rain or shine, no matter what, as long as we have school, you walk in here, you're taking a test. And I'm going to say this. You only are going to be prepared for this test if you guys truly study and you know what you're doing. If it takes you 5 minutes to complete one problem, you have not studied. If you are thinking and thinking and thinking and cannot remember, you have not studied. Would you agree? You have to be able to do this material quickly and efficiently without taking a lot of time, right? Knowing how to do it, but it taking you a lot of time to do it means you're not prepared, all right? Now, with that being said, let's go ahead and start. I'm going to not do the whole review sheet. I'm going to show you how to do each section, and then you guys can finish up and you can check your review sheet based upon my answers up here. Yes? So problems 1 through 3. Determine the quadrant that each angle lies in. So number 1, I'm not going to do. Number 2. This is a negative angle, so this is going to be negative 9 pi over 9. This is negative 18 pi over 9. Remember, whenever we did this, we looked at the denominator and we said that was going to be your pi, and that's how many sections you were going to have on the bottom and how many sections you would have at the top. Because this is a negative angle, it is opening clockwise. So I need all 9 parts of the bottom, and then I need 2 more parts of the top. So therefore, my angle is going to be here, and that is going to be negative 11 pi over 9. So that means I am in quadrant 2. Do we understand number 2? Number 3 is in radian measure. Since it is in radian measure, your brain needs to understand this is 0 radians. This is negative 0.57. This is negative 3.14, and this is negative 4.71, and this is going to be negative 6.28. Do you remember that, yes or no? Again, it's a negative angle, so it's still opening clockwise rather than counterclockwise. So I'm starting here, and then I need to have 2 radians. So it's going to go this direction, so I'm in quadrant 3. Do we all understand problem 2 and 3? Okay, I'm going to skip 4 and 5, not worried about them. Problem 6 through 13. Problem 6 through 9 says to express each degree measure as a radian measure using pi. How do I go from degrees to radians? How do I go from degrees to radians? You are simply going to be multiplying by pi over 180 because you want your degree symbol to cancel out. So if you're multiplying by pi over 180, the degrees and the 0 cancel out. This becomes a 5, this becomes a 6, so I have 5 pi over 6 and you are done. So for 6 through 9, you multiply by pi over 180 and reduce. What are you wanting to keep and what are you wanting to get rid of? You're wanting to get rid of the degrees, so since you want to get rid of the degrees goes on the bottom. You with me? So if we're looking at 10 through 13, and let's say we're doing number 11, I want my radians to cancel out, so I'm going to multiply this by 180 over pi. Pi indicates the radians, so that means the pi's cancel out, and you're going to have 180 divided by 3, which is going to be the 60. 60 times 4 is going to be 240 degrees. Do we all understand number 11? So on number 6 through 9, you multiply by pi over 180. On 10 through 13, you're multiplied by 180 over pi. Yes? Find the complement and supplement of the angle. Well, that's very simple. A complement is whenever you have an angle that is less than 90, and the angle is in quadrant 1. So if I look right here at number 15, and I want to do complement, I'm going to take 90 degrees minus 61, and that is going to give you 29 degrees. The supplement is 180 minus 61, and that's going to give you 119 degrees. So that's super easy when I give it to you in the degrees. But what happens whenever I give it to you in the radians on number 16? You have to figure out, you can convert them to degrees, or you can sit here and say, okay, well, where is this going to be at? This is 12 pi over 12, and this is 24 pi over 12. Why am I doing that? Because my denominator is 12. I need 11 pi over 12. Where's that at? That is going to be in quadrant 2, which means since my angle is in quadrant 2, do I have a complement? No. So this is going to be none because my angle is larger than 90, correct? So to find my supplement is going to be 180 degrees minus 11 pi over 12. Well, 180 degrees is pi, and pi is going to be 12 pi over 12. So that's going to give me 1 pi over 12. That is going to be the supplement. No, if my problem is given to you in radian, your answer must be in radian. If my problem is given to you in degrees, your answer must be in degrees. Yes? Do we all understand that? Are we good? Okay, now with that being said, the next section, next page, it says to find the arc length. Find the arc length, find the length of the arc on the circle with a given radius that is intercepted by a central angle of the given measure. I'm going to ignore this. You can use 22 over 7, or you can just use pi, I don't care. Okay, round out answers to the nearest 10. 22 over 7 is the closest rational measurement to pi. Do we all understand that? Now, what does the 2.7 represent? S is equal to r times theta. What does the S represent? Arc length. Do I know the arc length, or am I looking for it? You're looking for it, so it's undetermined. What is the r going to be? And what is theta? 330. I cannot use 330 degrees because 330 degrees is not found on a tape measure anywhere, right? It's not a degrees are not a unit of measurement that I can measure things in. Degrees have to be converted to radians. Radians can then be converted to be measured. Yes? So the very first thing you're going to do is you are going to convert your degree, which is 330 degrees, into radians. Do we all see that, yes or no? And that is going to be 11 pi over 6. Okay, so that is your radian measure. So you are simply going to plug this in, 2.8 times 11 pi over 6, and you're going to get 16.130. And that is going to be your answer. Do we understand that, yes or no? Number 19 and 20, the directions say determine a positive and negative coterminal angle to the following angles. Well, this is very simple. It's wanting the corkscrew angle to negative 7 pi over 5. Well, it's negative, so I need to get another negative. How do I get another negative? Subtract 2 pi. Well, if I'm subtracting 2 pi, that's the same thing as subtracting 10 pi over 5, yes? So what is negative 7 minus 10? Negative 17 pi over 5, right? Instead of subtracting 10 pi over 5, what am I going to do this time to find a positive? I'm going to add it, so what is negative 7 plus positive 10? 3 pi over 5. Do we see that, yes or no? We good on 19 and 20? Okay, the next thing says to find the point xy on the unit circle that corresponds to the real number t and evaluate if possible. And I want you to evaluate all 6 trig functions there. So what angle, what quadrant is 5 pi over 6 in? Well, how do I know it's in quadrant 2? Well, I know it's in quadrant 2 because if I were to draw it, this is going to be 6 pi over 6, but I want 5 pi, so this is in quadrant 2, which means I have negative positive. Yes? What angle corresponds to a denominator of 6? That's going to be the square root of 3 over 2, 1/2. But because I'm in quadrant 2, the x value has to be negative. So with that being said, I can simply now find my sine, which is 1/2, my cosine, which is the square root of 3 over 2, my tangent, which is going to be canceling out those 2 to give you negative 1 over the square root of 3, which is negative square root of 3 over 3. They're the same. The cosecant is the reciprocal of 1/2, which is going to be 2. The secant is the reciprocal of this, which is going to be negative 2 over the square root of 3, which is negative 2 square root of 3 over 3, rationalized. And the cotangent is simply the reciprocal of tangent, which is the square root of negative square root of 3. Now, do you see how easy it is whenever you put the ordered pair there? If you don't put the ordered pair there, you sit there and you stumble the entire time. Knowing the quadrant, this right here is thought process. That right there is your thought process. Do we all understand that? Having that as your thought process is extremely helpful for whenever you complete the problem. That is how you're going to do the next two problems. Then turn the page. This says evaluate the 6 trigonometric functions using the period as its aid. What does it mean when it says using the period as its aid? What does that mean? 5 pi. It's a corkscrew angle. What is a corkscrew angle? It goes around multiple times, not just one time, right? So if I'm at sine of 5 pi, I want to know exactly what does 5 pi correspond to. So simply subtract 2 pi. That gives me 3 pi. Is that still a corkscrew angle? Mm-hmm. It's bigger than 2 pi, so do it again. And that's going to give you pi. The unit circle equivalent coterminal angle is pi. What is the ordered pair associated with pi? The ordered pair is -1, 0, and that is going to be on the x-axis, which makes it a quadrant angle. Makes it a quadrant angle. It's really not in a quadrant, is it? I can't tell you that pi is in quadrant 2 or 3 because it's not. It's actually on the x-axis making up the quadrant angle. Do we all understand that? So what is the sine of 5 pi over 5 pi? Is going to be 0. The cosine is -1. The tangent is 0. The cosecant is the reciprocal of sine, which means the 0 goes on the bottom. Being 0 on the bottom is bad, so that means it's undefined. The secant is the reciprocal of -1, which is just -1. And the reciprocal of tangent is having 0 in the denominator, so again, that's undefined. Do we understand that problem, yes or no? That is also how you would do problem 24. Evaluate the following by using a calculator around 4 decimal places. You have to be in radian mode here, 26 is degree mode, and then 27 is radian mode. That r to the r power means that it is a radian. Do we all understand that? So that's just a simple plug and chug in the calculator. All right, 28 through 29. How do I do this? Pythagorean theorem, 100%. Okay? So all you have to do here is do a squared plus b squared is equal to c squared. So a is 1 squared, 2 is b squared, and c squared I don't know. So this is 1 plus 4. So this is going to be 5, which means the square root of 5 is equal to c. Yes? So you're simply going to do sine. What is sine? Opposite over hypotenuse. That's 1 over the square root of 5, which is going to be the square root of 5 over 5. What is the cosine? Adjacent, which is 2 over the square root of 5, so that's 2 square roots of 5 over 5. What is the tangent? That's simply going to be crossing off the square roots of 5 to give you 1/2. And if I know these, then the reciprocal of sine, I'm going to take the unrationalized fractions, and that's going to give me square root of 5. This is going to give me square root of 5 over 2. This is going to give me 2. Do we understand how to do the triangle ones? Yes? Okay, next page. Problem 30, it says use the given function value in the trig identities to find the indicated trigonometric values. If you don't have to use the trig identities, don't. Right? So if I know the sine of sine of 60 is square root of 3 over 2 and the cosine of 60 is 1/2, how do I find the tangent? That's going to be y over x, so that's going to be the square root of 3 over 2 over 1/2. The 2's cancel out, so it's just the square root of 3. Easy peasy. Do I need the sine of 30? Do I need to know any of that information to give you the sine of 30? What's the sine of 30? It is 1/2. What is the cosine of 30? Square root of 3 over 2, you already know that. And what is the cotangent of 60? The cotangent of 60 is the reciprocal of the tangent of 60. So that's going to be 1 over the square root of 3. So that's the square root of 3 over 3. Right? How important is that unit circle, folks? That unit circle is crucial, isn't it? Okay, 31. I'm not going to do 32. I will do 31. Now, if I know cosecant, what else do I know? So if cosecant's 3, what sign? 1/3. Very good. All right. What else? Cosine is going to be 4/3 square roots of 2, which means that's 4 square roots of 2/6, which is going to be 2 square roots of 2/3. Yes? Tangent, sine over cosine. So that's 1/3 over 2 square roots of 2/3. Bam, bam, those cancel out. So that's 1/2 square roots of 2. Square roots of 2/4. Yes? As soon as I see 90 minus theta, I think, hey, that's a cofunction identity, right? So what is the secant of 90 minus theta equivalent to? The cosecant of theta, which is given in our problem to be 3. Do we all remember that? Now, if you are uncertain how to do number 32 right here, I did this in your notes as part of your homework in class. Remember that? Make sure that you look that up. Scrolling down the identities, I did one very similar to 33 in class. Let's focus on 34. Okay, 34. I have 2 fractions that I'm adding together. When you add 2 fractions together, what must you do? I need a common denominator. What is my common denominator between cosine and sine? When in doubt, slap them together by multiplication. So I need each of these to have this denominator. Yes? So what did I multiply cosine by to obtain the new denominator cosine sine? So I'm going to drop down the numerator and I'm going to tack on what I multiplied the denominator by. Yes? I tacked on a sign in the denominator. So what I do to the bottom, I must do to the top, right? Go to the second fraction. What did I tack on to the denominator of sine to obtain the new denominator cosine sine? I'm going to drop down the current numerator, which is cosine, and then I'm going to tack on what I tacked onto the denominator. Do we see that? Okay? So what we're doing is now you're going to say, if I were to cancel the signs out, would I get the original problem? Yes. That means what you did is correct. If you cannot cancel out to get the original problem, then what you did was incorrect. Do we all understand what I just said? Okay? For example, if I had 1/2 plus 1/3, yes, my LCD would be a 6. What did I multiply 2 by to get a 6? So I drop down the 1 and multiply it by 3. If I want to get a 6 out of this 3, what did I multiply it by? So that's 1 times 2. So I'm going to have a 3/6 plus a 2/6. Same exact philosophy, but with 2 different trig functions. Okay? So what is sine times sine? Sine squared of theta plus cosine times cosine is cosine squared of theta. And since they have the same denominator, I'm going to write it as 1 fraction. What is sine squared plus cosine squared? 1. So now I'm going to go ahead and tear these apart. So that's 1 over the cosine of theta times 1 over the sine of theta. What is 1 over the cosine? And what is 1 over the sine? And I can put these in alphabetical order and rearrange them by the commutative property, and I am done. That's what it wanted it to equal, correct? Do we all see that, yes or no? What do you not like about it? It's the getting the common denominators. Do you understand the numbers that I did over here, the 1/2 and the 1/3? Okay, so that makes sense to you. So what your brain needs to understand is, let's make it just variables. Let's make them just something that we don't know. So we don't know cosine, we don't know sine, right? So cosine is considered the 2, and sine is considered the 3, right? So what I need together is cosine times sine. So what I did to get cosine sine on the denominator is I multiplied the original cosine, which is right here, by sine. So what you do the bottom, you have to do the top. So that's why we have sine times sine. You with me? Do you understand this step right here? Okay, let me finish this and I'll come back and I'll show you again, okay? Deal? All right. Okay, last page of the review sheet. The last page of the review sheet is solving for x given a triangle. As soon as you know the angles are inside the triangle and you're missing lengths, you want to start labeling an opposite adjacent hypotenuse. Okay? So what is 38 according to the degrees, 60 degrees? Is opposite of it. What is x? What trig function deals with opposite and adjacent? So the tangent of 60 is equal to opposite 38 over x. So x times tangent is equal to 38. So x is equal to 38 divided by the tangent. And you're going to pop that in your calculator, making sure you're in degree mode. When you do that, it's 21.94. Yeah, it has to be in degree mode. If you're not in degree mode, you're going to screw this up. Y'all understand that. Degree mode's crucial. 36 is the same way. So 37. It's the same exact thing except for you're reading it. It's a scenario. So a 30-meter line is used to tether a helium-filled balloon. Now, I'm going to be awesome. I'm going to be honest. A person's probably holding that balloon. Would you agree? So there's my person. Here's my balloon. And this right here is the 30, because that's the string attached to the balloon. Would you all agree? Okay? It makes an angle of approximately 75 degrees with the lovely ground. Do we see that? It says, using a trigonometric function to write an equation involving the unknown quantity, find the height of the balloon. Well, where's the height of the balloon? It's from the ground to the balloon. That's going to be x. So what trig function? Let's start labeling our lovely little triangle. What's x according to 75? What is 30? So what trig function deals with the opposite and hypotenuse? The sine of 75 is equal to x over 30. So how do I solve for x? Multiply both sides by 30. And what are you going to get x to be? Got to make sure you're in degree mode. I got 28.98 meters. Yep. Did you get 28.98? Yep. Okay, the rest of it is basically everything I've covered 100% is on the test. Okay? Does anybody need to go over anything else? Y'all don't like that last one, do you? You shouldn't mind it because it's simple. It's not even physics.
Well, like that's the stuff.
If I'm drawing a circle with radius 1, bam, there's 1. How many degrees are in that circle? How many radians? What? 2 pi. What's the circumference? Circumference is 2 pi r. So that's 2 pi times 1. So it's just going to be 2 pi, which is 6.28. Yes? Okay, the rest of the period is yours to finish that up. Test will be when? Monday.